Imagine a machine built in the 1970s that is still communicating with Earth after traveling farther than any human-made object before it. That machine is Voyager 1. When it launched in September 1977, nobody expected it to survive for decades. Its original mission was simple: visit Jupiter and Saturn, collect scientific data, and continue into deep space. But Voyager kept going. It reached Jupiter in 1979 and Saturn in 1980, sending back observations that changed what scientists knew about the outer planets. After Saturn, its path carried it farther away from the Sun and deeper into unexplored territory. For decades, Voyager traveled through the outer solar system. Then came the moment that changed everything. The Sun constantly releases charged particles known as the solar wind. These particles create a huge region around the Sun called the heliosphere. At the outer edge of this region is the heliopause, a boundary where the influence of the solar wind becomes much weaker and the surrounding interstellar environment becomes dominant. In 2012, Voyager 1 crossed that boundary. For the first time in human history, a spacecraft had entered interstellar space. That meant scientists could finally collect direct measurements from the environment between stars. And what Voyager discovered was surprising. Interstellar space is not simply an empty, motionless darkness. It contains extremely thin plasma, magnetic fields, particles and waves. Voyager detected persistent plasma activity that helped researchers measure conditions in the space between stars. Instead of studying interstellar space only through telescopes and mathematical models, scientists now had an instrument actually moving through it. But keeping that instrument alive has become increasingly difficult. In 2023, Voyager experienced a serious computer problem. The spacecraft continued sending signals, but the information arriving on Earth was corrupted and unreadable. The problem was eventually traced to its aging flight data system. Normally, repairing damaged hardware would mean replacing the component. Voyager is more than 15 billion miles away. So that was impossible. Engineers had to solve the problem remotely, sending commands across space and waiting many hours for the spacecraft to respond. After months of careful work, they managed to reorganize the affected software and restore usable communication. Voyager survived again. But another problem cannot be repaired so easily. Its power supply is slowly running out. The spacecraft uses radioisotope generators that produce electricity from the natural decay of plutonium. These generators have been operating for almost 50 years, and their available power continues to decline. Because of that, engineers have been shutting down instruments one by one to keep the spacecraft alive for as long as possible. Eventually, there will not be enough power to operate the remaining systems. The signal will stop. But Voyager itself will continue traveling through interstellar space. And attached to it is one of the most remarkable objects ever sent beyond our solar system, the Golden Record. It carries sounds, images, greetings and other information representing Earth and the people who built Voyager. It is essentially a message from humanity placed aboard a machine traveling into the unknown. Voyager was supposed to work for only a few years. Instead, it became humanity's first active messenger into interstellar space. And while its power slowly disappears, its journey continues. The spacecraft is still sending information across billions of miles of darkness. And the deeper Voyager travels, the more it reveals about the strange environment beyond our solar system. But some of its most fascinating discoveries are still waiting to be understood. One of the biggest mysteries Voyager 1 has revealed is what interstellar space is actually like. For a long time, scientists had to study the space between stars from a distance. They could observe it through telescopes and build mathematical models, but they had never had a functioning spacecraft directly measuring that environment. Voyager changed that. After crossing the heliopause, its instruments began detecting signals from the thin plasma surrounding the spacecraft. These measurements showed that interstellar space has structure and activity. It is not simply a completely empty region between stars. Plasma waves can travel through this extremely thin material, while magnetic fields influence the movement of charged particles. This is important because the boundary between our solar system and interstellar space is far more complicated than scientists once imagined. The heliopause is not a simple wall. It is a constantly changing region where the solar wind meets the surrounding interstellar environment. Voyager's measurements suggest that particles and magnetic fields interact across this boundary. That tells scientists something important about our solar system. The Sun does not exist inside a perfectly isolated bubble. Our solar system is constantly interacting with the larger galaxy around it. And that interaction may also affect the cosmic radiation reaching our planetary neighborhood. Voyager has therefore become more than a distant explorer. It is helping scientists understand the invisible environment surrounding the spacecraft's technology was designed almost 50 years ago. Its computers are extremely limited compared with modern machines, and many of its components have been operating far longer than originally expected. There is one final question surrounding Voyager 1 that may be more important than anything else it has discovered. What happens after the spacecraft goes silent? The answer is both simple and extraordinary. Voyager will continue traveling. Even after its instruments stop working and Earth can no longer communicate with it, the spacecraft will remain in motion through interstellar space. There is almost nothing in that region capable of stopping it. The machine that began its journey in 1977 will continue moving long after its scientific mission has ended. But Voyager's importance will not disappear with its final signal. The data it has already collected will remain valuable for scientists studying the outer solar system and the space between stars. Its observations have shown that the boundary around our solar system is much more complicated than early models suggested. They have revealed plasma activity, energetic particles and interactions between magnetic environments that cannot be understood simply by imagining the solar system as an isolated bubble. And that leads to a much bigger realization. Earth is not separate from the universe around it. Our planet exists inside the Sun's enormous influence, and the Sun itself exists inside the much larger environment of the Milky Way. Voyager is giving us a rare opportunity to study that connection. But there is another reason the spacecraft matters. It represents something that modern technology sometimes makes easy to forget. Exploration does not always require the newest machine. Voyager was built with technology that is extremely old by today's standards. Its computers are tiny compared with modern systems. Its power supply is slowly weakening. Its components have survived almost 5 decades in deep space. Yet it continues doing its job. That reliability was not an accident. The spacecraft was designed for a mission where repair would be impossible. Engineers had to make its systems dependable enough to work without human hands ever reaching them. And that design has allowed Voyager to survive far beyond its original expectations. Eventually, however, even Voyager cannot escape time. Its power will continue decreasing. More instruments will eventually be switched off. Communication will become harder. And finally, the last useful signal will arrive on Earth. After that, there will be no more measurements. No more commands. No more response from the spacecraft. But Voyager will still exist. The golden record will still be attached to it. That record carries a small representation of humanity into the galaxy. It contains greetings, natural sounds, images and information about our world. It was created during a time when nobody knew whether humanity would ever send another object this far. Now, decades later, Voyager has done something even its creators could hardly have imagined. It has crossed into interstellar space while remaining operational. It has survived technical failures. It has continued collecting measurements. And it has shown humanity that the region beyond our solar system is stranger and more active than we once believed. There is still much we do not understand. We do not have all the answers about the heliopause. We do not fully understand every plasma signal Voyager detects. We do not know exactly how the solar system's magnetic environment interacts with the galaxy on every scale. But that uncertainty is not a failure. It is the reason exploration matters. Voyager did not travel into space with every answer already known. It went there to discover what we could not learn from Earth. And every unexpected measurement has given scientists another question to investigate. That is how exploration works. You travel farther. You see something unexpected. You build a better explanation. Then you realize there is something even bigger that you still do not understand. Voyager 1 has repeated that process for almost 50 years. And even when its final signal eventually disappears, the questions it created will remain. Future spacecraft may one day travel beyond the heliopause with instruments far more advanced than Voyager's. They may discover things that Voyager could never measure. But those future missions will be following a path that Voyager helped open. A tiny spacecraft launched in 1977 became humanity's first operating messenger in interstellar space. Its mission was supposed to last only a few years. Instead, it became a journey across generations. And while Voyager continues drifting farther from Earth, one fact remains incredible. A machine built almost half a century ago is still sending information home from a place no human being has ever physically visited. Its signal is faint. Its power is limited. Its technology is ancient. But it is still there. Still traveling. Still exploring. And until the final signal disappears, humanity still has a voice listening from beyond the solar system.